Today we're going to be reviewing these operations with radicals, and this first graphic organizer is going to go over operations with square roots. So first, let's go over how to simplify a square root. So the first thing, this particular radical contains a number and a set of variables raised to different exponents. So the first thing we're going to do is off to the side, I'm going to simplify the square root of 84. So how do I simplify a non-perfect square? I find the biggest perfect square that goes into 84, which is 4. 4 times what is 84? 4 times 21. So I can rewrite the square root of 84 as the square root of 4 times the square root of 21. And then what is the square root of 4? It's 2. So I can actually rewrite the square root of 84 in simplified terms, which is 2 square roots of 21. So the first thing you want to do is simplify. So we're going to simplify the number first. And then let's look at the variables. So I have x raised to the power of 4, y raised to the power of 9, z raised to the power of, let's call it 1. I can write a 1 there. So the trick for simplifying the variables and the exponents is you just take half of the exponent and you rewrite that variable with the exponent outside of the radical. So for example, if I'm going to rewrite 2 square roots of 21, I'm going to write 2, and then what else am I going to move out there? I'm going to move out an x, and then I take half of 4, which is 2. But what do I do if I have an exponent that is odd? Well, I'm going to take half of it, okay, which if I do 9 divided by 2, it's 4.5. So y raised to the power of 4, but because it's odd, I'm going to leave one of those variables inside of the radical. So let's write that down here. So for variables, take half of the exponent, take half of the exponent, and then if it's odd, you're going to leave 1 inside. Oh, inside. Okay, so I'll show you what that looks like. So times the square root of 21, right, because this 21 is left underneath the radical. And then because I have this odd exponent right here, I'm going to leave 1 inside. And obviously z is going to stay on the inside. I don't have enough to take 1 out. So that's my answer. That's how you simplify that non-perfect square, and that includes variables. So now let's go over how to multiply radicals. So if I have the square root of 15 times the square root of 3, I can just multiply the radicands. That's the number underneath the radical, or what's underneath the radical, anything, numbers or variables. So 15 times 3 is 45. So I'm going to rewrite this as the square root of 45, and then I'm going to simplify it the way we just did, which, what's the biggest perfect square that goes into 45? It's 9. So I'm going to rewrite it as the square root of 9 times the square root of 5. And what is the square root of 9? It's 3. So this simplifies to 3 square roots of 5. So let's go over to dividing and rationalizing the denominator. And that's up here. So the rule is you can't have a radical in the denominator. It's simpler to divide anything by a whole number, or anything else but not a radical, okay? Because that radical is an irrational number, and so it's just very difficult to do that. It's simpler to have that in the numerator. So how do we do this? How do we get rid of the radical in the denominator? Well, whatever the radical is, if you multiply the numerator and the denominator by that radical, what does that do? It gets rid of the radical in the denominator, right? Because the square root of 3 times the square root of 3 is just 3. So watch how I do this. 12 times the square root of 3 over 5 times 3 equals 12 times the square root of 3 over 15, right? So what ends up happening? We move that radical to the top, right? That's where it is right there. And then I take the radical away, and if there's anything like this coefficient right here, let's call it that, this 5, I just multiply 5 times whatever that is without the radical. So 5 times 3. Now I can simplify it again. So the common factor between 12 and 15 is 3. So 12 divided by 3 is 4. 15 divided by 3 is 5. And I can rewrite this as 4 root 3 divided by 5. Let's move on to the next one. So using conjugates. So let's say I have an expression in the denominator that involves radicals. So the square root of 3 plus the square root of 7. Well, to get rid of those radicals, I'm going to multiply by the conjugate. What's the conjugate of the square root of 3 plus square root of 7? It's the square root of 3 minus the square root of 7. What I do to the bottom, I've got to do to the top. Whoops. 7 square root of 7 equals, so then I end up getting 2 times the square root of 3 minus the square root of 7 over, the radicals go away, and this simplifies to 3 minus 7. Okay, if you need a further explanation of this, why this happens, there is a lesson over this with multiple examples. So 3 minus 7, think of your difference of squares, right? And if you wanted to FOIL that square root of 3 plus square root of 7 times the square root of 3 minus the square root of 7, you would get 3 minus 7. So let's rewrite this. Square root of 3 minus square root of 7 over 3 minus 7 is negative 4. And again, I can simplify this. 2 and 4 have common factors. It's 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I can rewrite this as the square root of 3 minus the square root of 7 over 2. Don't forget your negative. You can put it in front of the 2. You can actually put it in front out there, which is what I like to do. So negative, don't forget that negative. And that's your answer. So now let's move on to adding and subtracting. So remember, we need like terms when we're adding and subtracting. So like terms in radical world are the terms that have the same radicand. That is whatever is under the radical. So for example, in this first one right here, I have 8 root 3 plus root 27 minus 2 root 3. Well, I already know that 8 root 3 and negative 2 root 3 are like terms, but what I don't know is this right here. Well, I can rewrite the square root of 27 in simpler terms. And if you need to, off to the side, the square root of 27 breaks down into the square root of 9 times the square root of 3. And I chose 9 because 9 is the biggest perfect square that goes into 27. What is the square root of 9? It's 3. So 3 root 3. So this actually can be rewritten as 3 times the square root of 3. So now when I rewrite this whole expression, 8 root 3 plus 3 root 3 minus 2 root 3. And now I actually, all of these are like terms, so I can combine them all. 8 plus 3 is 11, and 11 minus 2 is 9. So 9 root 3. That's your answer. Let's move on to this next one over here. Root 24 plus 12 over the square root of 6. So let's first simplify, because obviously looking at this, I see no way that we can add them because they're not like terms. Well, let's see if we can put them in like terms. So the square root of 24 breaks down into the biggest perfect square that goes into 24 is 4. So the square root of 4 times the square root of 6. Square root of 4 is 2. 2 root 6 plus, how do we simplify this basically division, or this fraction right here, with a radical in the denominator? Well, we need to rationalize it. So I need to multiply the numerator and denominator by the square root of 6, which gives me 12 root 6 divided by 6. Can I simplify anything? I sure can. 12 and 6 have a common factor, and that's 6. That gives me 2 over 1. So I can rewrite that as 2 root 6. Now I have like terms because these radicands are the same, and I'm going to combine them with the number that's out in front. So 2 plus 2 is 4. 4 root 6 is my answer. So now let's move on to the few examples that we have over operations with cube roots. So the cube root, if I take the cube root of something, that means I need 3 of something underneath the radical to be able to pull 1 out. So what I do is I do the prime factorization of the number. Okay, so 72, for example, obviously it's even, so it's going to be divisible by 2. 2 times what is 72? 2 times 36. Another even number, it's divisible by 2. 2 times what is 36? 2 times 18. Another even number, so it's divisible by 2. 2 times what is 18? 2 times 9. What is 9 divisible by? It's not even, so it's not divisible by 2, but it is divisible by 3. 3 times what is 9? 3 times 3. So now here's the prime factorization of 72. I need 3 of something to pull 1 out. I have 3 twos. So I can pull 1 out, but I only have 2 3s. I don't have enough, so they're left underneath this cube root here. 3 times 3 is 9. So 2 times the cube root of 9 is this simplified radical right here, the cube root of 72. So now let's move on to how we divide and rationalize the denominator of a cube root. So what you need, remember, to get rid of that radical, if it's a cube root, you need 3 of something on the inside. Right here, I only have 1. How many more do I need to get rid of that radical? I need 2 more. So what am I going to multiply the numerator and denominator by to get rid of that radical? I'm going to multiply it by the cube root of 2 squared because I need 2 more. What I do to the bottom, I've got to do to the top. So now let's rewrite it. That is what gets rid of that radical in the denominator. So let's make a little note. The denominator becomes, what does it become? Well, the cube root of 2 cubed. So the cube root and that exponent undo each other. Your denominator just becomes 2. So I'm going to rewrite the numerator. 3 times the cube root of, and let's go ahead and simplify this. 2 squared is 4 over 2. And we can't simplify it anymore, so that's our answer. Let's move on to the last and final problem. So 8 over the cube root of 9. Well, the first thing I'm going to do is rewrite the cube root of 9. I'm going to rewrite it as the cube root of 3 squared. So by doing this, by writing 9 as a product of squares, what do I need to get rid of that radical? Well, I don't need, I wouldn't need 9 squared. Now I need the cube root of just 3. I only need 1 more 3 because I need 3 times 3 times 3 to get rid of it, right? And pull 1 out. So here's what this looks like. So when I multiply the numerator and the denominator by the cube root of 3, let's rewrite this down here. I get 8 times the cube root of 3 over, now my denominator becomes 3, right? So the cube root of 3, which let's rewrite this right here. The cube root of 3 cubed looks like this. The cube root of 3 times 3 times 3. So I can pull out 1 3. Remember that cube root and that exponent undo each other. So that becomes 3. Let's write that down so you have it in your notes. Denominator becomes 3. And that's your answer. And hopefully this graphic organizer can help you, or has helped you review your operations with radicals. Good luck!